Two giants stand out in the history of physics. Isaac Newton, who lived in the 17th century, is responsible for laying the foundations of physics. His deep insight into the nature of mass and force resulted in his laws of motion for material objects. In the 20th century, Albert Einstein revolutionized our understanding of the physical world around us, with his deep insight into the nature of space and time. His theories laid the foundations for modern physics. Our current understanding of the universe would not be possible without the contributions of these two great physicists. Let us begin with Newton. As the story goes, Newton wondered why the apple always fell from the tree. In trying to answer this question, he was led to discover the laws of motion. These laws, called Newton's laws of motion, govern the behavior of all objects in the universe. He introduced the concepts of the mass of an object, the force acting on an object, and showed that objects will only move when acted on by a force. He also discovered the law of gravity. His theory of gravity explained how and why the planets orbit the Sun in the solar system. In the 19th century, Maxwell completed the development of the theory describing the electric and magnetic forces. What he achieved is quite remarkable. In short, he showed how the electric and magnetic forces are really two different manifestations of the same electromagnetic force. However, more spectacularly, he showed that light as we know it is simply one form of electromagnetic radiation. He predicted the existence of electromagnetic waves all traveling at the speed of light. This speed, which is denoted by the letter c, is 300 million meters per second, which is an incredible 670 million miles per hour. At the beginning of the 20th century, much of the physical world was extremely well understood. On the one hand, Newton's laws of motion described the motion of material objects with great accuracy. Newton's law of gravity was also in perfect agreement with experiment. On the other hand, Maxwell's theory of light and the electromagnetic force was also verified by experiment. It came as a complete surprise when Einstein proposed revolutionary ideas in 1905. Through his deep insight into the nature of space and time, he was able to show that Newton's laws of motion required a major revision when objects travel close to the speed of light. Einstein's theory of relativity explained the deep connection between space and time and energy and mass. We have already seen that the playground for the physical world is all of space and all of time. Einstein was able to show that the time elapsed between two events is not absolute. In fact, the time elapsed depends on the speed of the traveler. He also showed that the speed of light is the ultimate speed limit in the universe. Nothing can travel faster than light. One of his most remarkable achievements was to show that mass and energy are equivalent. This new law of physics is stated as E equals mc squared. Having shown that Newton's laws of motion required revision when objects travel close to the speed of light, Einstein then turned his attention to the force of gravity. Newton's law of gravity achieved spectacular success in explaining the orbital structure of the solar system. However, Einstein showed that even light feels the force of gravity. He predicted that light would be bent or deflected by a massive object like the Sun. This prediction was verified soon afterwards. Once again, the laws of Newton required a major revision.